and welcome back to a new video here on the Lötwig Fusel channel. In today's video we're gonna continue on in our boundless 2D game engine series. Now in the last video we have implemented application arguments through a interface, and what we now today want to do is we want to implement a bit of util stuff to add string conversion, and what we're going to do afterwards is we want to also put this to use in the arguments here so that we can convert strings around and have the arguments being read into like multiple ways, and then we might also implement like conversion functions so that we can convert strings from A to B. So what I want to do is I want to first add a new folder here, call it strings, so the utils for strings, and then what I'm going to add in here into the util package is I'm going to add a converter for the A. So we have a string converter. Now this is going to be the namespace bl2d util, util is just util, bl2d util, and then we're going to have a class string converter. This is the class that is going to do the lifting for us. Now what this is, the string converter is going to have, it's going to have a template argument t, type name t, and this is kind of like the destination type, or maybe we should also give it a name like target. This is kind of like the target where we want to convert strings to. And first of all, what I want to do is I want to first make sure that this one is never instantiated. So I'm going to delete everything in here that might be used. Oh, that's implemented by default, right? That's all gonna get deleted because we don't want to use it. And then what we're gonna have in here is we're gonna have a template type name source, and this is gonna be now our conversion function. And this is gonna be our conversion function with source std enable or type name equals type traits, include type traits, include string view, include strings, everything that we might need. Type name t, source or std enable ft, and we're gonna enable this function if source or std is equal is same. So if it's the same, if source and target are the same, then we are gonna enable that function, and this function is a std basic string target, so a string that has the same format as the target, because no, actually it's the same format as the source, because it's the target, right? Yeah, target is correct. So the output is target, and the string converter is something that is yeah, okay, so okay, do I want to do it like that, or am I just string converter of type, and then this is a static function, and it's gonna be called convert. Yeah, I mean it's kind of like double string converter convert, but I think it's fine. And this is a std basic string view. It's a basic string view of type target. So that's the idea. And this is now the conversion source. And what I'm gonna do here is basically just return the source, and it's gonna be converted to a string. This is the simple version of it. Now there is the complex version of that. A complex version of that if it is not the same. So if they are not the same, we're gonna do it differently, and we're gonna have a different function. This might actually be a problem, right? I'm just gonna return a empty string here to try this out, but this might have a problem. Templates are always a bit confusing, but in general this is the idea how I would tackle that. It could be that we need to change a few things and that we need to be even more explicit about source and target types, but I hope it works. We can already try this out. Now, first of all, one thing that we need to change is these were all references. I don't want to have them references anymore. This is a bad idea. Now let's remove the references here. And let's now use the conversion. First of all, let's include BL2D common hello util string converter, and then I can say return util string converter to char, and it's from my positional arguments at position. Now it's gonna kind of like try to match the template function and return the proper one. Now this one is quite similar. I'm gonna say auto iterator equals m named arguments find string converter to t from string. So it's copying to the internal type from the given string, and then what I'm going to return is string converter to char from m named arguments, or not m named arguments because we already have the iterator second. Dereference iterator second. How does the iterator work? I haven't used one in a while. Std unordered map int defined 0. So auto defined second. I think this is the way to do it, yeah. With the pointer operator or dereference, but that's fine. Where is it? It dereference it second. No, it's just gonna be it second. It second, and then we should gain access to the converted string. Now the same thing shall be done for the W string, but now it's converted to W char. The same goes for that. Converted to W char. And this hopefully works. Let's see if it even compiles, so if we're getting problems. We are getting problems, but probably because something else. Stay look. Identifier const. Where? Oh yeah. Okay. There we go. That's not good. But probably somewhere else. Return. Oh, come on. Return. Oh! Yeah. That's not a good idea to have return in here. Okay, still problems, but that's okay, that's okay. Just come to a conclusion. Overloading virtual function, yeah, because they are now in a different format. So we need to remove them here as well. And let's see if it works. Probably it says something already defined or stuff. Cannot convert from const std vstring. Ah, yeah. Convert, of course. I'm using my converter completely wrong. Oh man. Yeah, this is what you get if you are only used to write code with IntelliSense, and then there are templates. And then you are getting screwed over, and you haven't used templates in quite a while. I haven't used C++ in quite a while in just this tutorial series. And then you end up with mess like that. Convert. Okay, so this is now probably the thing that I have already foreseen. Could be. Could not deduce template argument from vstring. Yeah. But why? Oh, what? But it says it cannot deduce it. SCD basic string char straight BL to D string converter char convert basic string view source or char. Yeah, that's the problem. Because this is kind of like, no, this one. But this shouldn't be too big of a deal, actually. And like, if it is... Oh, I see. The target should alias, in this case, to char. And if you then supply a char, this should be disabled, right? But it's not. Source and target are because they... I might need to add a function. If I do basic string view like that, and what if I do another function? I don't have a cursor. I always laugh if I don't have cursors, because cursors are something that you don't need, right? Cursors are so super useless. So you can just get rid of these. Let's add a template type name source. Let's make a static std basic string. Let's make a basic string out of target. And then let's maybe call this one convert, and let's make this a const std basic string of source. So this should be deducible. And then what we're gonna do is call this one source, and then what we are doing is we are gonna return a std basic string view of source created on source. And then it's converted to a string view, and maybe this helps it inline this helps it deducing the types. No? Convert, no matching overload found. Source and char. But it shouldn't be. Teacher main. This is this function here. We're converting from string. So where are you? There, in this line. Named arguments find string converter t convert from string, which goes to that one, and that convert can't find it. Why can you not find it? I can find this as well, because like it is trying to do it from char to wchar, so it's a basic string here of char. But this should be identical. It should be able to find it because it's target and target source. It's a basic string view. Maybe do I tries to find. Why are you also considering that one? I mean, you should consider that one, but target and source are the same. This one is just voice creating a string view, but this doesn't help. So we have source and target here. I mean, I could just right? I could just I could just deeply hardcode this, right? Why should I make this fancy if I don't need to? Why am I not just doing it differently and say target is that, and then I just say class, or let's maybe even make this a struct. This makes this even simpler. And I could even make this completely functional and just with operators, right? And I could go and say template struct string converter char, and then completely get rid of these. Just make this completely empty. Maybe let's do something like operator std basic string target operator std basic string view target source return std basic string view target source, and then we do the same here. But now if we are on char, it's gonna be interesting because we are always gonna output a char, and we are starting from a char, and we are creating a char. What? Oh yeah, of course I'm going to a string. A basic string. Like that. And then if I go to wchar, or from wchar, I am just gonna now return an empty one, and then later on gonna define how they implement as well. So this is a better way of doing it. Wchar, now source can be done here, and this can be done there. And now at least we should have a step that works, and the arguments now of course need to be changed. Basically what I want to do is something like that now. The string converter is now instantiated, and then instead of convert, just execute it with the operator. Now of course I pasted in shit. String converter of char, instantiated, put that in. String converter of t, instantiated, put that one. String converter of char, instantiated, put that in. Instantiated, put that in. I just would have needed to take it like that. Let's see if that works. This should work because it's way simpler and way less stuff. Cannot find, oh yeah, okay. It cannot open that because it doesn't have a dummy.cpp in here and it's not generating code. So there we go. I don't want to have that in string. I don't know why Visual Studio still has this bug. I haven't updated Visual Studio for quite a while though. This at least should compile. And it does now need to actually do string conversion, and wait, it would take way too long for that. So C++ string conversion, C++ string to W string. There is no proper way of doing this. There is like the Windows way of doing it, and this is like the normal one, but this will not work. The problem is that there is a problem. Cases where standard explain the results on different platform. Node old, I don't know. I just want to use that one. This might not work. I'm not quite sure if this currently does work. But let's try it out. So, code convert and local. This will give us deprecated warnings, but it's not a problem. vstring converter. This is now which way around? Convert string to W string. So it's the other way around currently. Let's start with the other way around and then I can adapt this. So the W string converter. And then the white is that one. So return string narrow to byte UTF source string. This is the narrow string source. But this one is, I think, not compatible. But we should be able to do it like that from bytes. Yeah. This works like that. So we have the converter and the converter does that. UTF-8, UTF-16, and now we need to adapt this for the other way around. String converter. Or is it also a W string converter? W string converter. Char. From bytes. 2 bytes. I think this is the way you do it. And if I run this, I'm gonna get problems, right? Should I? Warning. Yeah, a lot of warnings. Silence all. No, I wanna have silence CXX17 codec header deprecation warning. You can see? Okay, this one is not even working at all, but at least I wanna silence all of that. Warning. Deprecated. Deprecated in C++ doesn't provide. Equal, non-predicated, consider using. Yeah. The thing is, Microsoft wants us to use the Windows functions, but I don't want to use these because they are not cross-platform. So what we do either is we basically just go into our build system and say, hey, build system, you're just going to ignore this for the whole project. So there is at some point a, boundless 2d.lua BL2T application, which is a BL2T project. And if we are creating a BL2T project, we're doing stuffs and we gonna silence a few things. And we're gonna silence that one. Alright, and this generates everything. Regenerates everything, and now we can recompile and see if we are still getting problems. We'll probably still get problems because we had issues. And now we have that one. Okay. Char MB state. Yeah, that's all nice, but I do want to see my one. So this is the wchar to ASCII. Is it just that one, or is it also the other one? No, it's just that one, right? So I probably have made a mistake there, like the other way around. There's also a remove vstring convert completely in C++ 26. Abstract introduction. Why? Yeah, history. Did we get proper YNT in that one then? Probably not. But let's see. String to W string. So W string to string. Oh, come on, this is... I love how everything is always gonna go... how people are always set up converter, use converter. So it's a W string converter of... converter 2 bytes. This is correct, I think. 2 bytes. W string converter type wchar. They're doing this completely different. They have the... yeah, here it is. This is the one that I was looking for. S to VS and VS to S. 2 bytes. Converter type. Vchar, Wchar, OTF8, Wchar, Wchar. They're both the same. Are they? Really? Possibly. It's the same one that can convert both ways around. Okay, then fine. Alright, so changing these lines of codes makes it easy to convert. I don't know why this took too long, but yeah, I'm sorry for that. I'm sorry that we are doing too much shit for a simple thing like that. Now, one thing that I want to add is I want to add a bit of features that it's a bit more browsable. Currently, you can't really browse everything. So you can, what I want to add is I want to add a way to kind of like get the key set. So what I want to have is I want to have a function for kind of like getting some information. So get positional count is what I want to have in here, and then I want to have a virtual std vector of std string get named keys. So get the named keys, the number of keys that are available, and get named W keys. These are the new 3 functions that I want to add to the class. And basically how they are going to be implemented is quite simple. I think I didn't have the override at all with the other ones. Maybe let's add these ones in here as well. Now, of course, Trend Micro also scans while I'm recording. It's always a joy. Const override. Const override, and now I just need to implement these. So positional count, just positional argument size. And then keys are actually quite simple. std vector, std string keys. And then for auto. Well, actually, let's say for auto it equals named arguments begin. It also would say not equal gleich end and plus iterator, so iterate over them, return the keys, and then how do I convert? Well, keys pushback util string converter to char, and I want to convert it first. So the key, not the value, is what I want to convert to that. And then also we have it with wchar. So what I can do now inside of my application, in my dummy app, basically iterate over arguments. So for size ti, I smaller, args get positional count, I plus plus, and I can then say spd log info arg whatever is, and then I can say they can see they can get like the normal string now at position I, and then they can do the for auto key in args get named keys. They can say spd log. You can already see that I'm using the ASCII version of them. Now the arg with the name has the value, and I can say key. Then can say args string key, and this shall already do a lot of string conversion already. We could also use the W version of that, and it's completely failing. That's nice. Because there's no W string here. All right. Yeah, no threads found. This is nice. And now you can see, okay, it has overwritten my arguments. My command line arguments, probably. Argument 0 is already there, but it seems like it has overwritten the debugging stuff. Yeah. Let's do this position 1. A is on. Position 2. B is hello. Let's maybe make this even a better argument. Hello world. And then we have position 3, and we have C equals true or something like that. And then we have position 4 and stuff. And then we can see, we're going to say apply and OK. And now we should get a bit more. Yeah, you can see like argument 0, 1, 2, 3, 4. We have 4 positional arguments. One is the exe part, that's 0. And then the arguments, argument 1, A was just 1. Then we had hello world, and then we had true. Okay, so this is way too much work for getting the things done, but I am sorry. Yeah. And I think it's fine. It's fine that we have put a bit more time into that. And string conversion, and telling Microsoft to just be shh and not telling me that something is deprecated. But yeah, we have a bit of a nice iteration of our arguments, and we have done string conversions, and everything is a joy, everything works as it should. And we could also use W strings as well. But if we are using W strings, it gets a bit... Oh, I see, we don't even have... Oh, yeah, okay. Yeah, we can see you can also use W strings here. I think spdloc has support in that for the code, and then you can see that we also work with W string, and it also works. And it doesn't make a difference, but it's a W string, and that's like the whole idea of that code base, right? We have a interface here. It is all implemented in a proper way. It is all using templates, and it's all like nicely straight outlined and ready to be used with more complicated code. Yeah, we might also have later on a bit of a proxy about these arguments, but for now I think this is enough infrastructure that we have done. I think now we shall actually go into details like modules and tasks and a bit more of the joy that actually makes up our application. So yeah. Thank you for watching. See you in the next video. Make sure to like and subscribe, and have a nice day. Bye.